Welcome to our channel. Myself is Gautam VM, studying in Sri Venkateshwara College of Engineering, Bengaluru. First semester, Vonda section, Applied Chemistry for Triple E stream. Subject code BCHEE102. Today we are going to discuss about sensors. Sensor. A sensor is a device that detects and responds to some type of input from the physical environment. The input can be light, heat, motion, moisture, pressure, or any number of other environmental phenomena. The output is generally a signal that is converted human readable display at the sensor location and transmitted electronically over a network for reading further process. Definition: a device that responds to physical stimulus and transmits a corresponding signals to is known as sensor. Physical stimulus are such as heat, light, sound, pressure, magnetism, or particular motion. Example: you can find a different types of sensors in your home, offices, cars, etc. Working to make our lives easier by turning lights, by detecting our presence, adjusting the room temperature, detect smoke or fire, make us delicious coffee, open garage doors as soon as our cars is near the door, and many other tasks. All these are many other automation tasks are possible because of sensors. Sensors are the type of transducers. Transducers are the device that convert from one form to another form. Example of transducers are sensors and actuators. A sensor is a device that changes a physical parameter to electrical output, while an actuator is a device that converts an electrical signal to physical output. Difference between sensors and actuators. Basic comparison. Sensors, actuators. Basic converts physical parameter to electrical output. Converts an electrical signals to physical output. Sensors convert physical parameter to electrical and actuators convert electrical to physical. Placed at input port and placed at output port. Outcome: electrical signals are produced by sensors, heat and motion produced by actuators. Examples: cameras, microphones are example for sensors. Actuators are LEDs, lasers, loudspeakers, etc. Classification of sensors. Sensors are then classified into active, passive, electric, biological, chemical, radioactive, analog, digital, photoelectric, thermoelectric, electrochemical, thermo-optics. In first classification of sensor, they are divided into active and passive. Active sensors are those which are require external excitation signals or a power signals. Passive sensors are the other and do not require any external power signals and directly generates output response. The other type of classification is based on the means of detection used in the sensors. Some of the means of detection of electric, biological, chemical, radioactive, etc. The next classification based on conversion phenomena, input and output. Some of the common conservation of phenomena are photoelectric effect, thermoelectric effect, electrochemical effect, electromagnetic effect, thermo-optic, etc. The final classification of the sensor is analog and digital sensors. Electrochemical sensors. Applications. Electrochemical sensors are considered as attractive tools for determining important molecules or biomarkers that are used for the diagnosis of diseases and disorders. They are used for the monitoring of toxic level of different substances, input quality and environmental controls. The biosensors are application areas of these sensors extend to medical and biomedical applications, process control, bioreactors, quality controls, agriculture, bacterial and viral diseases, industries, wastewater control, etc. Types of electrochemical sensors. There are mainly three types of electrochemical sensors: potentiometric, ampermetric, and conductometric. Potentiometric sensors. A local equilibrium is established at the sensor interface where either the electrode or membrane potential is measured and information about the composition of sample is obtained from the potential difference between two electrodes. Ampermetric sensors explicit the use of potential applied between a reference and working electrode to cause oxidation and reduction of the electroactivity species. The resultant current is measured. Conductometric sensors. These are involved with the measurement of conductivity at a series of frequencies. Conductometric sensor. Conductometric sensor is used to measure the tendency of a medium or electrolyte solution to allow electric current to pass through between working electrode and counter electrode. The conductivity depends on the charge on the ions, mobility of the ions, and the degree of dissociation of the analyte. Conductometric sensors are the type of impediometer sensors, as this technique is used to analyze changes in capacity. To obtain changes in capacity value of the electrode, AC power supply is usually applied. Metal oxide based on conductometric photosensor. Examples. Usually a gas sensor that uses metal oxide nanoparticles consists of heating layer or wire, conducting electrode, and sensing film which changes its resistance up to exposure. Conductometric gas sensors changes their electrical conductivity upon to target gas. The interaction of target gas with sensing metal oxide layers occurs either adsorption by diffusion. Optical sensors. Optical sensors are the device used to detect or measure the change in the intensity of light in general or interaction with object or light and generate a corresponding electrical signals. Example, detectors like photodiode. Colorimetric. A colorimetric involves the measure of color and used for measuring the concentration of biochemical compounds in colored solution. It measures a absorbance and wavelength between 400 to 700 nanometer in the visible spectral of light of the electromagnetic spectrum. Thermometric sensors. These are based on the measurement of thermal changes during interaction between sunlight and receptor, in which thermal changes are converted to measurable change in temperature. Electric method. It involves measurement of current, voltage, or resistance in relation to concentration in a certain species solution. Optical method. The optical method are based on how the sample acts towards electromagnetic radiation. Example, colorimeter sensors. Advantages. The method is much faster than chemical methods. It requires small quantity of sunlight. They gives accurate result. Disadvantages. The instruments are expensive, the concentration range is limited, and specialized training is needed for the operation. Optical sensors. Sensors are based on the transduction of interaction of electrochemical electromagnetic radiation with chemical species are called optical sensors. These sensors are devices that convert light energy into electrical signals. Application used in smartphones for adjusting the brightness of the screen, used in smartwatches to measure the heartbeat and person, used as a water level indicator, used in medical and healthcare services. Thank you for watching.